Hello and welcome. Today I would like to talk about Pytorch and their installation and their tutorial. And so, first of all, I want to apologize for the fan noise. I need that for my K80 GPU. Requires an enormous fan, and because I'm running a noise filter on my microphone, whenever it's quiet, you don't hear the fan noise. But whenever I speak, you can hear the fan noise and it makes my voice sound weird. So sorry about that. I hope you can tolerate it. Anyway, let's get over to the desktop. And so on pytorch.org, there's a Get Started page, and then there's Get Started locally. And so I want to talk about that. There's this tool on the Pytorch page. If I go right to Pytorch, you'll see that there's a tool here that helps you decide how you want to install this. So I chose the stable version, Linux, Conda, Python, and Cuda 11 here, and it gave me the command to run, which is this, which I ran it inside of a virtual environment. I created a Conda virtual environment. If you don't know how to do that, you should learn. There are a lot of videos on how to do that. And then, so after I ran this, we can go back over to this getting started locally. And let's go to the top here. So there's some prerequisites, like NumPy, and so we're going to see where that is in a little while. I believe there's a requirements file that we can run. So this talks about the different versions of Linux you can run it on. And it wants Python 3.6 or greater, so this talks about how to install Python if you don't already have it. It's I'm on Pop! OS, which is a version of Ubuntu, so this is the command for that. And then it tells you how to install Anaconda. I highly recommend Anaconda or Miniconda. I run Miniconda, but Anaconda is just as good, so you should install Anaconda if you haven't done that. This is one of the most important tools available to data scientists, this and Jupyter Notebooks. All right, so to install the Pytorch binaries, you need either to have Anaconda or pip. And then here's how to install Anaconda. It's this curl command. If you don't have curl, it's a sudo apt install curl. And this is how to install pip, which is the Python installation package manager or something like that. And then it says if you don't want to type pip3, you can simply pip to pip3 binary. So you do a which pip3, it'll tell you where it is, then you can, it's probably in user bin, so then you would just do an ln-s to user bin pip3 space user bin pip. I think that link takes the old and then the new. That's the order for it. All right, so just follow along all of these things, and once it's installed, you should be able to run this verification here. I'm just going to copy this. I actually think that, no, there's no copy thing out here. And then I'm running Visual Studio Code here. So let's see, let's make a new Oops, that's not the one. That's the one I want. One of these guys, new one of these guys, and then I'll do a Control S, which is save here, and I'll call it first.py here. And in Visual Studio Code, you have to name it .py if you want to have this run button up here. Until you run it, it thinks it's just a text file, and so there's, I'm sorry, until you name it, it thinks it's just a text file, so there's no run button. So once this is here, I've got Vim emulations running, so I have to hit A for a pen. See my cursor changes from a block to a blinking line, and now I can just do a Control V. And here we go. We don't want that. And now I can just hit that little guy here, and you'll see that down here in the terminal, it actually ran that notebook or that file first.py, and stuck it down here. You can also do this in a notebook if you want. I like notebooks, but sometimes it's just easier to work in code. So it's these days it seems to be my preference to put everything inside of files like this. All right, so we get that output, so we're fine. And then we want to run these lines here. Well, we've already imported Torch, so we really just need this. Torch.Cuda is available, and what we can do is we can say device equals Torch. Cuda is available, and then we can print device here. And Control S will save, and it'll fix the formatting, and then I'm just going to run that. And you'll see that device equals true. Now, maybe device is not the best name for it, but we can now use this. Once we know that Cuda is available, we can use that in our code. So here's the prerequisites: install Anaconda, install Cuda, right? If you have a Cuda-enabled GPU. So in Pop! OS, that is a sudo apt install Cuda latest, I think it is. Let me just take a quick look here. Yeah, here it is. It's this one here. Sudo apt install system76-Cuda latest. That will install Cuda drivers, and then you also need to install what is it? It helps to spell it right. Sudo apt install system76-cudnn -10.2. I think they have 11.2 now. But maybe I made a mistake back here when I said that I chose 11.2. I guess I chose 10.2. They've updated the tool since I did the installation. All right, so let me just run back here. So yeah, we have to make sure that Cuda is installed if we want to use our GPU, and if we have a GPU, we want to use it because this is very slow on the CPU. And then it says go over here to GitHub, and we can follow the steps here. So I should have a directory here. No, I'm in the wrong spot. CD code. So I did not create this yet. You run up to the top here and grab a copy of this. Do a git clone. I'm not going to bother to fork this because I've got too many fork repositories already. All right, so this should just take a minute. You can see down here that I'm using the transformers virtual environment. That's where I'm getting my kernel. So one of the cool things about using VS Code is that I can set my kernel from any directory, which makes things easy sometimes. So this is actually copying over quite a bit of stuff. I hope it's not grabbing all the data sets. All right, so now I've got a Pytorch directory. And there's the requirements.txt. Let me just do a more of requirements.txt here. And you'll see these are all of the dependencies that we're going to need for our tutorial. So we want to make sure that all of these things are loaded. And the way we do that is a pip install -r requirements.txt. And all of these should be in there already. So you can see everything was already satisfied. And sometimes you have problems when you do this. You'll see that you've got some packages that are, let's say you had an older version of NumPy, and it wasn't allowing you to install something from here. You can do a pip uninstall whatever the package is that's causing you trouble. Install this and then do a pip install NumPy, for example, and that should give you the right version then. So when you run into problems with doing pip installations, there are ways to get around that. And sometimes they're difficult, other times they're very easy. So it's worth a try. Most of the time when you have trouble doing a pip installation, it's because you're using too new a version of Python for your virtual environment. All right, so now we've got no, that's not it. CD, we were in notebooks, right? Notes. That's where we want to be. All right. So we've got our environment set up. We've installed what we need to install, and we've tested it here. And you can do this in the terminal, you can do it in the notebook, you don't have to do it in VS Code. I just am getting to really like VS Code. All right, so let's go back here to the tutorial. And here it is, tutorials are up here. And this is going to go over some of the things that we just went over, which is fine. This is pointing, I guess, to the examples directory that we have out on I thought we had an examples directory here. Yeah, I'm not sure about that. All right, so let's get started with this. So there's some modules here, like working with TensorBoard and so on. But I think what we want to do is go in order. So we can come over here to the sidebar. And we can do the learn the basics here, and this talks about how to run the code in the cloud if you don't have a GPU, or to run it locally, which is what we've just set up to do. And then it suggests that we start with a quick start if we are familiar with neural networks. Otherwise, start with tensors here. And yeah, it's pretty good. I'm going to rate this high. And so let's go to the quick start. And so it gives you some explanation here, and then it gives you some code. And look at this, it gives you a little button to click here. So let's just copy that, and let's go back to here. I'm going to delete all this. Just delete it and go into append mode and put that in here. So we're importing a bunch of modules here: Torch module, Torch utils, .data. So we need a data loader so we can grab our data sets, and then we're importing the data sets. So Torch. There are a bunch of data sets available. So Torch Vision will include the data sets for all the vision kinds of things. And I can't think of the names of the other ones right now. My memory is going. But in any case, Torch Vision is specific to vision mod. It's the vision module. That's where the data sets are that are vision types of data. And so we're also importing these other modules here and matplotlib so that we can view some graphs later. And now I'll go back here, and there's some more explanation. Oh, here, Torch text will have the data that for text. Torch audio will have a bunch of data sets that are for audio. So if you want to do natural language processing, you can get your data sets from Torch text. And they give you a full list here of all the stuff that's in So you can take a look at that. And then here's the next bit of code. We just copy it here, run over here, and paste it. All right, so what are we doing here? We're downloading the training data from open data sets, right? So up here, let me just hide this for the moment. Up here, we import the data sets, right? And that just gives us access to it. It gives us some code, access to some code that will allow us to get the data sets. And so here, we download the training data. Training data equals datasets.fashionmnist, right? And then we are, this I guess is the method. That says it's a class. So this is a class, and then I guess these are properties. So root equals data, train equals true, download equals true, transform equals to tensor. So we're going to grab this data and we're going to stick it into tensor. The tensor is a rectangular matrix, and I guess it's going to have everything padded out so that every single entry is the same size. And we're also going to get the test data from the same location, the fashion MNIST, and so these are the properties for that. But we just made this object here. We haven't done anything with it yet. So let's figure out what we need to do with it. And you'll see when we run this, it's going to, it's actually going to download the, let's see, so I just told you we're not doing it, we haven't done anything with it yet, and I'm wrong. So I'm going to run this. And I guess it's not showing this, it's not showing you here anything because I've already run it, so it's already downloaded. So you're not going to see all of these messages. What you do see here is a message saying that, warning, the NumPy array is not writable, blah, blah, blah. And so immediately when I saw this, I thought, oh, great, it's not working. And that's not true. This is normal behavior. I don't really understand why we're getting this warning. I suppose that if I knew more about this software, this warning might make some sense to me, might be helpful in some way. But at the moment, it's not helpful to me. I would have rather that I hadn't seen it because it sent me down a rat hole. So you don't have to go there. You don't have to go down that rat hole. Just know that you can ignore this message and get on with it. And so what's next here? Let's go back to the tutorial. Now we're going to need this batch size. We're going to set the batch size here. Just copy that. And down here. And paste it. Well, maybe I was right. Maybe nothing has been done with it yet. I think this is where it starts to, I'm going to do a control left quote here, single quote. That gets rid of the terminal. One of the things that I don't like about this IDE is that it's kind of difficult to scroll to the right location sometimes. You go past it or not far enough. All right, so we set the batch size equal to 64, and we need to set a batch size because we can't push everything through at once. The system will run out of memory if we do that. So we have to send things through in batches. So here we create the data loader. Remember up here, we imported data loader. And down here, we're going to use it. So we create a train data loader, and we tell it we're going to use the training data, right? That's this thing up here with all of this object, with all these parameters set. And we're going to use the batch size. And same thing with the test data loader. We're going to use this object that we created, and we're going to use the batch size. And then for x comma y, in test data loader, we print the shape of x and print the shape of y and the data types. So let's just run that. And here we go. Shape of x is here. Shape of y is there. And you can see that 64 is the batch size. And this, I guess, is one dimensional, and then it's 28 by 28. So this is going to give us a 28 by 28 rectangle. And we're going to pass 64 of these through at a time, I believe. So let's go back here, and we've gotten the correct output. So now we're going to create a model here. We're just going to grab this, run back here. Paste it. And let's take a look at it here. Get rid of the terminal for a minute. Device equals Cuda if torch.cuda is available. We saw this earlier, right? And of course, they're doing it correctly. Rather than putting true in there, they're putting Cuda in here. And else device equals CPU. And here's where we define the model. It's a class, a neural network from the nn.module. And we're going to define it all here. And so this is a object-oriented programming. So we need an initializer, and we do a super init, and then we tell it that we want it flattened, and it's a type linear ReLU stack. It's equal to nn.sequential. So this is the method that we're using, and these are the parameters for the method. So we're going to have a 28 by 28 image, and I guess 512 of those. And then we're going to use an activation function, ReLU here. And then we're going to have another 512 by 512 linear layer. And then another activation function, and then another linear layer. I'm sorry, I'm saying this wrong. This is going to be 28 times 28, whatever that is. That's going to be the input, right? So if you think about it, you've got a you've got an image. Let's say it's a black and white image. It is 28 pixels by 28 pixels. We're going to flatten that out. We're going to make one array out of it that's going to be 28 by 1, 28 times 28 by 1. So 30 by 30 would be what? 900. So this is going to be a little smaller than 900. And then it's going to output 512. So there'll be 512 nodes at the other end of the layer. And then the activation function. And then the next layer is going to take in 512 and it's going to put out 512 and then another activation function. Then the next layer is going to take in 512 and it's going to output 10. And there'll be another activation function. And so here we're defining the forward pass for it, which is going to return logits here. And then we're going to create a variable called model, and that's equal to a neural network going to the GPU, to Cuda. And we're going to print the model out here so we can take a look at it. So I don't know if you saw that. It went by pretty quickly. I'm just going to full screen this down here. So it came by, it said using Cuda device, which is what we wanted it to say. And so we're happy about that. And then, so here's the shape of our tensor. It's 28 by 28. So that's correct, because down here, we've got in features 784. I said it's close to 900. That's fairly close to 900. So I guess that's the answer. 28 times 28 is 784. Out features equals 512. Bias equals true. Then ReLU. Then 512 to 512. Then ReLU. Then 512 to 10. So we're going to get 10 labels out of this thing. And we'll see a logit for each label, and I guess we're going to want to choose the largest logit. We'll probably do a softmax on that so that we can see it as a percentage of 1. All right, so I think there's more here for optimizing. All right, so if this is confusing you, if this is too much and you're not getting this, then the thing to do is to skip the quick start and start with tensors here. And so you learn about tensors. And it's the same thing. You copy from here and you paste in there and then you run it and you see what it does. And they take you through here bit by bit. And this is all very easy stuff to understand here. Here we've got a variable data, and we're passing in a list of lists. Right? This is the square bracket thing here, means it's a list. So this is a list, and this is a list, and both of these lists are inside this list. And that's really what a matrix or an array looks like. And we're going to take that and we're going to pass it through here, the torch.tensor. So this makes it into a tensor, which is still a list of lists. And so on. You just, continue on down here. You'll see that if you print it out, you get the tensor here, which is a list of lists that's inside of parentheses here. So this is what it looks like when it prints out to the terminal. All right, so obviously I can't go through the whole tutorial. This is probably a pretty long video already, but that's the gist of it. And hopefully you can get started with this. and create something interesting. Learn about how to create models and use them to solve real world problems. Anyway, I thank you for joining me, and please like and subscribe and all of that kind of stuff. Thank you very much.